Hello to Dr. Lee Xiao Li. This is our MAT183 Assessment 3. So, here are my group members. First one is Bibi Maria Amira, myself, Filza Erinachia, and the last one is Al Bakri. For our title is Words of Shadow. This is our introduction. For application of differentiation. What is differentiation? Differentiation is a process of finding a function that gives output of the rate of change in one variable to another variable. Why we use differentiation? We use differentiation to determine if a function is increasing or decreasing. A function is increasing if its derivative is always positive. A function is decreasing if its derivative is always negative. Differentiation also allows us to find rates of change. For example, it allows us to find the rate of change of velocity with respect to time. The example of application of differentiation in real life that we could apply to is a speed car. How to solve? Let's start from here. A 6-feet man walks at a rate of 3 feet seconds away from a street light, that is 21 feet above the ground. At what rate the length of his shadow changing when he is 8 feet away from the light?
Step 1. Identify and understand. X is length between man and the street light. S is the length of the shadow from the man. Length of the street light is 25 feet. Height or length of the man is 6 feet. This is the speed of the man, 6 feet man, walking away from the street light is 3 feet per second, which we identify as dx over dt. And understanding the question wants us to find dx over dt when x, length between man and the street light, is equal to 8 feet. Step 2. Formula. We are going to use these two triangles. The first triangle, we're going to use formula tan theta equal 21 over x plus s. That is the first equation. And the second equation is tan theta is equal to 6 over s. And we're going to use simultaneous method and put 1 in 2, and we will get 21 over x plus s equal 6 over s, and we're going to cross multiply on it, and we get 21s equal 6s plus s. 6s, bring it to the left side, and 15s is equal to 6x.
Step 3 is to differentiate the equations. Take the derivative with respect to t of both sides of the equations. Simplify the equations. We have 15 ds dt equal to 6 dx dt. Step 4 is to evaluate and solve the equations. From the question, we know that the xdt, which is the rate of light between the man and the street light, is 3 feet per second. So we put the value 3 into the equation and we end up with 15 the xdt equal to 18. Then we move 15 to the other side and divide 18 with 15. Simplify the equation and we will get 6/5 as the final answer. Therefore, the rate of length of the man's shadow changing is 6/5 feet per second.
In conclusion, by using related rates can be applied in various situations, and it can be solved by deciding what the variables are, finding an equation related to differentiating both sides of the equation with respect to time, using the chain rules and substitute them into a differential equation.
The references that we use for this group project is the revision guide, Calculus 1 book, and also Calculus Tropical Practice book. That's all from us. Thank you.